I had a high school teacher who used to say to me, Murtagh, he says, nothing ever sinks in with you until you hear it twice. And I'm saying that because I'm seeing a lot of familiar faces out there from the presentation yesterday, so there's going to be a lot of similar material here. However, a slightly different emphasis, because Caitlin obviously went before me and her focus was on goal 3, and I'm going to emphasize a little bit more on goal, a little bit on goal 4, but more specifically on goal 5, just because I largely, even though my position at the White House is all-encompassing on space weather and preparedness, but the science piece is my background, so I'm going to touch on that a little bit more. Again, I'm going to provide an overview of the national strategy and the mechanisms behind it, the motivation behind it, the process that drove the whole the development of both the action plan and strategy, and of course the critical next steps. Now that we have an implementation plan, what are we going to do with it? I've mentioned in many presentations before that I really loathe when I see great efforts going forth in the development of national strategies, and I see that strategy ending up on a shelf, and a day, a week, a month, a year, or 2 years later, and you realize not much has come from that great effort. We do not want to see that happen, so I'll talk about how we're going to make sure that doesn't happen. On the motivation, I'm going to jump into a few different things here. One of I'm going to state the obvious, but it must be stated, and that is, of course, our reliance on advanced technology for everything we do today, and the vulnerability of this technology to space weather was one of the huge motivations behind the White House and the development of a national strategy. Loss of any of these systems, whether it's GPS, it's satellite systems, other satellite systems, communication satellite systems, or of course the electric power, for any loss, may it be for hours, days, weeks, and especially long term. That's one of the big distinctions on space weather, as many of you know, is that we could possibly be looking at a long-term outage of some of these technology, and are we prepared for that? That's one of the big questions we have to answer. So needless to say, as we become more and more reliant on this technology, we've got to make sure we're in a place where we know how to manage life without it, should we be without it, or what we need to do so we don't get into a position where we are without it. Busy chart. It's supposed to be busy. In the back of the room you probably can't see much. What I'm just trying to show here is that one of the distinctions, one of the unique pieces of space weather, it is a global threat. It's a distinction we made as we embarked on this effort of the White House. It's a little bit different than a hurricane. We know the consequence of a Category 5 hurricane making landfall in a major U.S. city. We know what it looks like if we see an intense earthquake, but largely it's a regional or localized effect. It can be very large region, some of the particular impacts. But on space weather, when those big eruptions occur on the sun and they come sweeping past the Earth is a little dot of sand as this massive eruption from the sun sweeps past. The whole Earth gets impacted. In an extreme event, Carrington-like event, we're not sure exactly what the impacts would be, but in a much lesser event back in Halloween of 2003, we got a little taste of what it might look like. The event back in that period of time, it was actually a series of major eruptions that occurred over a 2-week period, impacted technology around the world. We recognize cheap satellite systems where various countries were impacted, power grids, the power grid in Malmo, Sweden went down. There was lots of transformers damaged in South Africa, and many, many other examples of impacts on technology around the world. But again, just that distinction that it is a global threat, not a local or regional threat. One thing I wanted to point out too, and I need to do this just a little bit more often, because if there was a little bit of a criticism on the actual national strategy, it does focus largely, of course, on an extreme event and what an extreme event might do to the country. But it should be pointed out all the time. Space weather, like regular weather, occurs all the time. And the consequences of space weather have been felt quite regularly. So I'm going to just, on more occasion now, throw a few slides up there showing that, yes, no big extreme events in the last decade or so. The last decent-sized storms we had were those Halloween storms. But even in more moderate storms, just to show how this stuff can affect technology, March of 2012, you'll see some of the headlines here. Solar flare knocks out light-squared satellite. Well, it was actually the biggest communications satellite in geosynchronous orbit got a whack from one of these coronal mass ejections. We thought it would be out for a couple of hours. Meanwhile, 3 weeks later, it was still down. You'll see on the Stars and Stripes, recent solar storm interferes with Air Force satellites, so national security systems will be impacted. And there, even on the bottom, people often ask about the impact on aviation. This was one particularly interesting one. You'll see in SURFA, the FAA has 3 stages or 3 phases of alarm alerting system when there's an aircraft potentially in distress. The first one is the INSURFA, and the INSURFA is issued when there's no communication with an aircraft for 30 minutes or more. There's federal aviation regulations that require continuous communication. When they're without communication 30 minutes more, it is a problem. Is it a big problem? Well, that'll be the next 2 levels. But back in that period, again, March 2012, these INSURFAs were issued because we were not able to communicate with some of the aircraft in the higher latitudes. Why? Space weather. It's very important for situational awareness when you are not communicating with an aircraft or you are not unable to communicate with an aircraft. Why is that the case? So if you're able to turn to the alerts and warnings you might have got from the Space Weather Center, you'll realize, okay, it's very, very likely maybe space weather that's impacting this. And even more recently, and there's a couple of stories behind this, and this is just last month. Again, just to demonstrate that space weather occurs all the time. We had an event last month, didn't make much. I don't know if anyone in the room even heard about this particular event. But I can tell you it did make its way into the government circles and into the Department of Homeland Security and ended up at my desk. And the question was asked, Bill, we just had a solar eruption and it shut down the airspace over Sweden. I was just Sweden, I'm not quite sure why, and the question was asked, Bill, can that happen in the United States? Because now, you'll see the Weather Channel headline, massive solar storm halts air travel in Sweden. It wasn't massive, it was a relatively small event. I can't control the media. But this wasn't a big event, and it shut down the air traffic. The United Kingdom have embarked 4 or 5 years ago, 2012, back 2008-9 time frame, they had very little interest in space weather. Then what happened? Not a space weather event, but they had their airspace shut down because of a volcano erupting 1,000 miles away. And there was a whole lot of elected officials in the United Kingdom scratching their heads saying, oh, wow, I didn't know this could happen. What else out there could happen that we don't know about? People got up there and they said, well, actually, sir, ma'am, there's this thing called space weather. Should we get an extreme event like that, we would have similar effects to what we saw with the volcanic ash situation by some accounts. That changed the whole dynamic in the United Kingdom, and within a couple of years, actually it was just last year, they opened up a 24/7 Space Weather Operations Center, and even in the last discussions between the Prime Minister and the President of the United States, space weather was on the agenda, so I was very keenly aware of it in the United Kingdom. So lots of messages in that, in the event that occurred just last month. But getting back just to touch on one, when folks in the White House and elsewhere asked, Bill, can an event like this happen in the United States and close our airspace down? What was the answer? The answer is, we're not so sure. We don't know. And it's again part of the motivation behind this national strategy to get to a place where we do understand exactly what might happen as best we can given the limitations in our understanding of the science and indeed the impacts. Another huge motivation, of course, behind the development of a national strategy was our awareness, our keen awareness, our growing awareness of extreme space weather. And you've all heard about this Carrington event back in 1859, 1-2 September. It was a magnificent event. We measured the intensities of these storms often with a proxy measurement of the southern extent of the northern lights, the aurora borealis, and this particular event, what must it have been like in Cuba and in Central America for those folks to look up in the sky and see the northern lights? A reflection of the intensity of the geomagnetic storm back then. But our awareness that in a storm like this, should it occur today, what might it do to the nation? And one of the reports that came out, of course, was from Lloyd's of London, working with a science company called AER, and they had all sorts of dire suggestions of what might happen, including trillion-dollar impact, outages that would extend past a year. And then one of the big things was highlighting the fact that the vulnerability, perhaps greatest, not only just in this nation, but across the world, is that location, that place between Washington, D.C. and New York City. Because of our latitude, because of our geology, because of our proximity to a large conductive body of water, the Atlantic Ocean, salt water, and because of the very interconnected grid that we have up in this northeast, all creates that kind of vulnerability. Another big piece that motivated the development, the necessity for a national strategy, was the tremendous work that we saw going across government circles over the last couple of years. On the Hill, for those who heard yesterday, Congressman Franks gave us an update on some very, very positive steps in the House, and indeed there's efforts in the Senate as well to introduce the grid, and we heard yesterday the SHIELD Act being folded into the energy bill. The U.S. regulatory action, the Federal Energy Regulatory Commission has stepped up, and we're seeing the development of standards now which did not exist years ago, where the operators of the grid must have operational procedures and do vulnerability assessments. As Caitlin said, space weather is now in the Strategic National Risk Assessment. FEMA are doing lots of good things, and then the international scene across, especially in the United Nations, all sorts of efforts underway to address the issue of space weather, may it be in the aviation side of the House, satellites, and the Committee on the Peaceful Uses of Outer Space, and many committees within the United Kingdom. But all these good things happen. We recognize one thing we really did need, and that was a cohesive all-of-government strategy to address this issue. We're past the point in suggesting we're at that point where we believe this is obviously a real threat. We need to do something about it. So we put together a task force. The White House ordered the development of a task force in the summer of last year, and by November 2014, the SWARM, the Space Weather Operations Research and Mitigation Task Force, was established and tasked to develop a strategy and an action plan. And Caitlin, of course, emphasizes, was one of the tremendously valuable pieces of this whole effort as we brought the Homeland Security side, the DoD side, FEMA was in there with the National Security Council, and we ensured that when we were going to deal with the private sector, owners and operators, we would be able to work through DHS and all the great connections they have to make sure they were included. But you can see on the task force across so many different departments, within the Office of the President, it wasn't just the Office of Science and Technology and Policy, but we also had the National Security Council involved. And of course, key there was the Office of Management and Budget. We need to know what we can and cannot do, where the limitations are when, during the budget cycle. So we need them involved, and then across all the various agencies. So it was very much a multi-agency initiative. Caitlin emphasized this, that it was not just then, of course, inside the White House and inside government circles. We had the public comment period where we had it out for public comment for a 30-day period. Got lots of good feedback that we incorporated into the strategy. And Caitlin also talked about the 6 strategic goals, but now she focused in largely on 3. I want to make a few comments here on goals number 4 and number 5. Goal number 4 in particular has this critical action, and it is the vulnerability assessment, comprehensive vulnerability assessment we must do across all sectors. It's what's missing right now. There's bits and pieces here. There's some great work done here and there and everywhere, but we want just some comprehensive effort. The UK have done one. I think it's very good, where we can point to a specific document that gives us some sense of what are the vulnerabilities to aviation, what are the vulnerabilities to GPS systems, and so on. So that's a key action called out in Goal 4. The deliverable will simply be the report itself and the timeline, which is very important in these action plans, as we've identified the agency responsible, what the deliverable is, and the timeline to provide that deliverable. In Goal 5, a couple of key actions. So Goal 5 largely focused on the science and research piece. So it was NASA, it was NOAA, it was the National Science Foundation, the Air Force Research Lab, Naval Research Lab, other folks involved in the science and research and the operations, issuing alerts and warnings. But just to give you some examples that I'm very confident we'll see happen because of this strategy in the very near future. And this is one. DOI, the Department of the Interior, specifically the U.S. Geological Survey, USGS, in coordination with Commerce, with NOAA, will sustain existing ground-based magnetometer network and enhance the network through the installation of new observatories, new magnetometers. We understand, it's clearly identified in many documents, that the distribution of magnetometers around the country right now is lacking. These things don't cost many millions of dollars. They're low cost. Why are we not doing this? We will do it. We called it out in the national strategy. We will budget for it. Deliverable will be and achieve a sustained measurement, data continuity, and a complete installation of new observatories. The timeline, sustained measurements enhancements completed within 5 years. That doesn't mean we're going to start in 5 years. It means we're going to start in this coming months and years and be complete within 5 years. I'm going to stick with the same theme because there's reason, continuity for it. The Department of Interior, again the GS, will identify and fill gaps in the MT surveys beginning with the northeastern United States. One of the things that are lacking right now in our ability to observe and forecast is understanding truly the geology of the ground beneath us. The conductivity and the resistivity plays big into how electric field is formed, how induced current is created, and how it impacts the grid. Again, not a huge effort here, cost-wise, but it will be tremendous benefit should we put a little bit of effort and money into getting this done. And again, we called it out as an action. The deliverable is simply to complete the improvements so we have across the entire continent assessment of the conductivity within 1 year of the publication of this plan. I can tell you already efforts are underway to make this happen. But these are the kind of things we've got over the course, working with many of you in this room and many others in the science community. We've sat around tables for the last couple of years saying, if only we did this, we need to do that, why haven't we done that? These are all those gaps that we tried to fill here as much as we can in the action plan. We've called them out. We've called out the responsible agency. We put the timeline. We'll bring OMB and other budget people into the room, and we'll make this happen. So, to finish up with the way forward, how do we make it happen? What we're going to do is form an oversight body in the White House. We've had this task force managed from the White House. We'll continue to manage it in the implementation phase from the White House. It'll be quite similar, I think, to the task force in that we'll put together that body. It'll be led by Office of Science and Technology Policy, working again with the OMB, working with the National Security Council. On the agency side, I want somebody representing, like we had Caitlin, maybe it's someone from FEMA or from her office, the DHS. The science side, maybe NOAA or NASA, again, co-chair in this whole initiative. Picture us meeting twice or 4 times a year in the White House. This big spreadsheet's been formed. We have a meeting coming up on Tuesday where it'll be laid out. Here's the 8 actions that are out there. Here's the columns that say who's responsible. Here's the point of context. Working groups will be formed to make sure we pull off these actions. The accountability is there. The reporting will be done again twice a year. And one key piece here, will house it under the NSTC, the National Science and Technology Council in the White House, to ensure the perpetuity through this cannot end with the change of an administration. So past this administration, we'll have the agencies engaged, we'll have it under the NSTC, so regardless of who the president is, regardless of who the chief scientist is, and so on, this thing will live in perpetuity, and we will get it done. One last thing I just wanted to show, just to give you a sense of how things are working already. This was back in July of this year. The memorandum comes out from Sean Donovan, who's the Director of the Office of Management and Budget, along with John Holdren, the Director of the Office of Science and Technology Policy. And this memorandum is the multi-agency science and technology priorities for FY 2017. So this is the document that gets sent out to NOAA, to NASA, Commerce. Everybody gets this document. Here's the administration's priorities. Here's where we need to do, where we start focusing our budget. This is going to help guide you. This is what we want to see in your budget. And you'll see down at the bottom, space weather observations and research and development are essential to address the growing societal needs for accurate, timely space weather information. Agencies should prioritize investments in space weather according to the National Strategy and Action Plan. Very straightforward. That's it. So, again, thanks very much. I appreciate the opportunity. I certainly appreciate the great work that InfraGard has done, and the Triple Threat Power Grid exercise document, Chuck, is very, very good. I've shared it with my colleagues in the White House. I think we are going to see a lot of people using it. One interesting piece, too, the strategy and the action plan is the great enabler. And regardless of what's in there, the fact that it's risen to this level at the White House, I've got lots of different interactions over the last month and 2 in the last week on different states across the nation that are trying to figure out how to incorporate space weather into their preparedness plans, and are planning one's a 4-hour workshop in other states looking at doing a 1-day exercise, all based on the fact that now this has been released. It has amplified the issue is the key point here. And because of that, we'll see more and more effort across the nation to build resilience against this threat. So thank you very much for everything you do.
One question, please.
With the microphone, please.
One of the key things we've been mentioning here is the importance of telecommunications. We're building FirstNet to be there for such emergencies. I've heard from people who are involved with FirstNet, who are familiar with the top leadership developing the RFP that FirstNet is developing to build this, that this leadership is not concerned about EMP or GMD and has no intention of making FirstNet resilient to this concern. First question is, what can you and Swarm do to help assure that FirstNet is resilient and we don't build something that will not be there at the very time we need it most? And the second related question that was asked to Caitlin, we have 5 or 10% of the energy produced in the U.S. by the federal government. Bonneville, Tennessee Authority, along the Colorado, to have a proof of concept effort to show how to make a hydroelectric power plant resilient, the transmission lines. Caitlin responded by saying Bonneville is working on some efforts on the 1 or 2 substations. That's nice. That's something. But what about having a proof of concept for the full path from the generation of the hydroelectric power all the way down, as well as making sure that FirstNet is indeed resilient, which might mean having its own alternative power sources?
So on the issue of an engineering solution, I think you're touching on there. The last point I made, I think, when I was talking about that strategy and action plan, is how it is an enabling document. And that, some people look at me sometimes and say, that's Bill Murtagh, the space weather forecaster guy, may not be interested in the engineering solution. I assure you, I believe that that is the key element here, is to build in, and so I'm very keen on what I'm seeing, the actions on the Hill right now, when Congressman Franks and the SHIELD Act and the other efforts, the legislative efforts on the Hill, focus largely on an engineering solution, and I support that fully. Now that we've got the strategy and action plan out on the street, and obviously just went out, and our first meeting is on Tuesday. Now working with the departments, with Energy in particular, Homeland Security, and the Federal Energy Regulatory Commission, we are now going to embark on whatever efforts we can to enable those activities, the pilot projects, whatever is necessary. We'll be reaching out to some folks in this room on how best to do that. There's lots of good work done and literature out there that already helps us get to where we need to be. So it'll be, we'll start moving on it now.
And FirstNet?
What is FirstNet?
What?
It's the new emergency communications network for first responders. So
Oh,
all the
okay.
stuff you have in your LTE cell phone could be useful for the FirstNet.
Yeah. Yeah, I'd have to get with you offline and discuss that separately.
Please, that's one of the most, not only one of the most important telecommunication systems that's going to be built new,
Yeah.
so we can do everything built in, but it's also one of the most important to be there in case of the problem. So it's one of the most important things that has to be done and needs to be done very soon before the RFPs are committed to.
I think it has to be done by 2018.
2018, okay.
Well, I've got a question. Given the emphasis up on the Hill right now, being put in both of the energy bills into microgrids, and now this new awareness about space weather, is anywhere in the White House any thought being given to looking at a clean slate approach to the grid? Take a white piece of paper and design it as given what we know today as opposed to what was happening 120 years ago. Yeah. And the other thing is, your colleague mentioned in her earlier presentation about trying to build into the future systems mitigation things. Has anybody come up with some sort of a possibility, a what if, on how to do that?
On system mitigation, as in with like hardening devices, blocking devices? Is that the question?
Yeah, like ultra wideband.
Yeah.
That's coming.
Oh.
You're going to build these things into the wideband, ultra wideband?
Yeah, I have no idea. I'm the space weather person. I can't speak for the engineering folks in the Department of Energy on that specific issue. Like I said, for the technical solutions to engineer around it, it's certainly something we want to do, but it would be some of the existing proposals out there may to be blocking devices and such. Thanks. Okay.